Welcome guys. So in the last class I dropped the rules for partial fractions. That's these rules that you can see here, right? So now I would want us to solve examples. So this video will just be straight up examples. In fact, this is the assignments that we were given, so I'll just solve it straight up. Okay, so question, I'm not blocking. Question 1. Find the Laplace inverse of (3) s squared plus s squared plus 12s plus 2 s minus 3 s plus 1 cube. Solution. Now, from the rules of partial fractions I listed, just follow this thing step by step, the way I would solve it. Now, the first thing you do, this exact question, you write it here. 3s squared plus s squared. So this is 3s cubed from the question. 3s cubed plus s squared plus 12s plus 2 over s minus 3 s plus 1 cube. So just follow this thing step by step like I'll be doing. Now, from the rules of partial fraction, we're going to break everything down into partial fractions. Okay, remember when I talked about something like this in the previous class? To break this thing down into partial fractions, okay, this power is bigger than this. You know, from the rules, they said the degree of the denominator must be lower than that of the. So let me just say this is. Let me say this is s squared, and this is s, and this is s plus 4. So you see here we have 3s. So the highest degree here is 3, while the highest degree here is 2. So if I were to break this into partial fractions, it's going to be like this: a over s minus 3 plus b over s plus 1 plus c over s plus 4, just like the rules states. So from this question now that we want to solve, we'll just break it into partial fraction using the rules. You see, here we have s minus 3. If your denominator looks like this is how your partial fraction would look like. So you just write it a over s minus 3. Now our second denominator looks like this. So this is what we'll do: plus, you see, b1 over s plus 1, then plus b2 over s plus 1 squared, then you say plus b3 over s plus 1 cube, just as so stated in the rule here, this rule 4. So you just expand it and spread it out, okay, till you have something like this. Now let us begin to solve. So we're going to look for, basically what we want to do is to find the values of these constants, these terms a, b1, b2 and b3. So just follow me step by step. Now a, to find the value of a, you just go back to what you have in the question, the numerator, okay? So you write it out: 3s cubed plus s squared plus 12s plus 2. Then the denominator, you write it out, but you would keep what you have here. That's what is under this a, is s minus 3. So you skip this one and write everything you have here, which is s plus 1, which is power of 3. Then just watch what I'm doing. Now you see this one you covered, you open it, change this sign. What you have here is s minus 3. So change it to plus 3 and say s is equal to 3, which is plus 3. Then you solve, you get the value for a. So anywhere you see s, you substitute 3. So you put 3 inside. So this becomes 3 into 3 cube plus 3 square plus 12 into 3 plus 2 over 3 plus 1 raised power of 3. Okay, so using our calculator, we just put in the values to save time. 3, just see what I'm doing. So I'm just solving it automatically. So the answer is 2. So A, you see A is equal to 2. Okay, A is equal to 2. Okay, now you note this down. So we are done with the value of these constants, this one. So now let us look for B1, B2, B3. Now when you have something like this where you have to spread it out into B1, B2, B3 and starting with the power of 1, 2, 3, the first constant you would look for would be B3. Okay, so you just write it the way we wrote it. So you look for the last one, which is B3. So you write it down, 3s3 plus s squared, just the same way we did for the A, 12s plus 2 over, now this is the power for B, so you cover it and you write what you have here, s minus 3. What you have here is plus 1, so you convert it to negative, s is equal to minus 1. So you type it in your calculator. So s is equal to minus 1. So the answer is 3. Okay, the answer is 3. So B3 is equal to, you can see, I hope you can see my calculator as well. B3 is equal to 3. So the next thing we would look for now is B2. So that's how we find it. A, then B3, B2 before B1. Now how do we find the value for B2? You see this B3 we have here. Let me write it out. 3s3 plus s squared plus 12s plus 2 over s minus 3. Okay, now this, what's at the top? We want to use this formula to solve. B2 is actually v du minus u dv over v squared. Okay, so what is on top is u and what is below is v. Okay, so u is equal to 3s3 plus s squared plus 12s plus 2. Du differentiates, that's 9s squared plus 2s plus 12. Now v is equal to s minus 3 and the v is equal to, if you differentiate what you have here, you have 1. Okay, so put everything inside this equation. So that B2 becomes v s minus 3, du is 9s squared plus 2s plus 12 minus u is 3s cubed plus s squared plus 12s, hope you can see, plus 2, and the v is 1 over v squared. V squared is s minus 3. Okay, so now the same thing, you put s is equal to minus 1. So s is equal to minus 1. So you can just type everything straight into a calculator, or you solve it. So B2. So I don't want to solve everything straight up, so I'll just type with my calculator. That's the previous one. Okay. So I'm just using A for S because my calculator has no alphabet S. 9 S square plus 2 S plus 12 minus 3 square plus square plus 12 square plus 2. Is that plus 2 now? Yep. Times 1, not necessary, into S minus 3 square. So S is equal to what? Minus 1. Okay. So minus 35 over 8. I'm feeling I made a mistake here. I'm so feeling I made a mistake. B2 minus 35 over 8. So let me just run through it again to be sure. Okay, let me just pause. Okay, yeah, I can see the mistake. This is 3, 8, 3. So the answer is minus 4. Minus 4. So B square, remember this is 3A cubed. So B2 is minus 4. Okay, now to find B1, see what you have for B2, this one here. You would find du, you find u, du, and dv. So this numerator is u, this bottom one is v. So you find du and dv, same way we did for the previous one. So you can start by expanding it. Okay, so how do you expand now? S times this is 9 s cubed plus 2s squared plus 12s minus 27s squared plus minus 6s minus 36 minus 3s cubed minus s minus 12s minus 2 over s square minus 6s plus 9. So let me just take out like terms. So 9s cubed minus 3s cubed, that's 6s cubed. Okay. 2s squared minus 27s squared, that's minus 25s squared minus s squared, that's minus 26s squared. And 12s minus 12s goes 0, so we're left with minus 6x. Minus 36 minus 2, that's minus 38 over s squared minus 6s plus 9. Okay, so I hope you understand what's happening here. So we're looking for B1 now. Now what is, okay, we're looking for B1. Okay, this is still B2, I haven't yet found B1. So we're going to find u and v. So u is equal to 6s3 minus 26s squared minus, this is still B2, sorry, minus 6s minus 38, and du is equal to 18s squared minus 52 now, 2s minus 6. Okay, then v is equal to s squared minus 6s plus 9, and the v is equal to 2s minus 6. Okay, so I have to transfer this on that page. So it's my list of standards. So let me just write it. Let me just continue working. Yeah. So I would see what's happening. Okay, just continue working this. That would see what's happening. So B, oh, wait a minute. Good. Just hope we saw what I was doing. I just hope everything I did showed in the camera. Okay, good. So B1 is equal. So B1 is equal to V du minus U dv over V squared. So we're just going to write it. What is V? S squared minus 6x plus 9. What is du? 18s squared minus 52s minus 6 minus U dv. What is U? 6s cubed minus 26s squared minus 6x minus 38. Minus 38. dv is 25 minus 2s minus 6. Remember, everything here is in numerator, all over V squared. Square. S is equal to minus 1. Okay, so you use your calculator just the same way, put the value of minus 1, everything. You're going to get B1 as 11 over 8. Okay, you're going to get B1 as 11 over 8. So what this means is that, look at original Laplace transforms, where our A is 2. So we're going to write it out. Remember 2 over s minus 3 B1 that we just found is 11 over 8. And like this, 11 over 8 over s plus 1 plus B2. We found B2 to be minus 4 over s plus 1 square. Okay, and we found B3 to be 3 over s plus 1 cube. Now from our standard transforms, where's my list of standard transforms now? List of standard transforms. Is that what I'm solving on? So for your standard transforms, 2 over s minus 3. You see, you have s minus 3, that's like s minus 8. So the transform is EAT. So let me just explain it instead of going back. So this would now be, this is 2 is a constant, so you just bring out 2. Now this is my f of t now. E, since you have minus 8, it turns to plus 3t. Okay, for this case, this is a constant, so you bring it out, 11 over 8. E, since it's plus 8, it turns to minus 1t. Then here is minus 4t. This is standard transform for this, e minus t, and here is plus 3t square e minus t. So this is the answer. So everything has to do with knowledge of standard transforms. So this is your answer. So learn your standard transforms and all of that. The next thing we would look at, I want to look at question 2. So we'll just solve these two questions, then you'll be able to solve the rest by yourself. This question 2 is a different ball game altogether. So we'll solve it, then you'd solve the rest by yourself. But if you wouldn't be able to solve the rest, you just let me know in the comment section, and I'll see if I can create videos for them. Question 2. Question 2 says, if f of s is 5s squared plus 8s minus 1, s plus 3, s squared plus 1. Okay, so that's what we want to solve. So like I said, first thing to do is to write the equation out by this corner. 5s squared plus 8s minus 1 over s plus 3 to s squared plus 1. And like we always do, a into s plus 3 plus, now you see this one, this looks like this. Okay, so that's what we're going to use. I'm going to say b s plus c over s squared plus 1. So that's how we would solve it. So the next thing we're going to do is to find a. Find a is very simple. We'll write the numerator, which is 5s squared plus 8s minus 1 over, cover what you have here. What you have here is s squared plus 1. This is plus 3, so it's going to be s is equal to minus 3. Put that in your calculator. Put that in your calculator, so you have 5s squared plus 8s minus 1 into s squared plus 1. S is minus 3. So a is 2. So the next thing to do is to find b and c. Now this case is different. It's different. We have to find the roots of this equation. The root of this equation. Okay. Now what we will do is to, let me just explain to you. Let us multiply through by s squared plus 1. If you multiply through both sides by s squared plus 1, so s squared plus 1 cancels s squared plus 1 here, so you'll be left with 5s squared plus 8s minus, okay, let me write it. Multiply through, multiply. Sorry about my handwriting. Multiply through by s squared plus 1. So that's the denominator of this bs plus c, because we're looking for bs plus c. Write it to find bs plus c. So you multiply through by s squared plus 1. So you multiply this side by s squared plus 1, multiply this side by s squared plus 1. So you s squared plus 1 will cancel. So you're going to have 5s squared plus 8s minus 1 over s plus 3 at the left hand side. And the right hand side you have a into s squared plus 1 over s plus 3 plus bs plus c. Now to find the roots of this equation, mode, you can solve it by yourself using the quadratic formula, or you just use your calculator. There is 1, 0, and 1. Just so this equation is correct. So my calculator is giving me my roots as I. Okay. So now what you do is that anywhere you see, anywhere you see s, you put I, you substitute I. Okay. So let's proceed. Now if you substitute I here, normally this will turn to 0, because I simply means root minus 1. So with minus 1 square, you'll be left with minus 1. Minus 1 plus 1 is 0. Anyways, let me just solve it. This will be 5i square plus 8i minus 1 all over I plus 3 is equal to, putting I here turns everything here to 0, so you'll be left with plus bi plus c. Okay, I square is minus 1, so you'll be left with minus 5. So what you have here, let me move to the next page. So what you have here will now be minus 5 plus 8i minus 1 over I plus 3 is equal to bi plus c. This would now become 8i minus 6, okay, over I plus 3 is equal to bi plus c. Okay, so in taking the conjugate, let me just take the i's to the left hand side, so that I'll have minus 6 plus 8i over 3 plus I. Now minus times 3 minus I over 3 minus I is equal to bi plus c. So I'm trying to rationalize the basic denominator. So this becomes minus 18 plus 6i plus 24i plus 8, right? I times I is minus 1 minus minus plus 8 over, I hope you understand what I'm doing, is basic mathematics, over 9 I times I plus I times I is minus 1 times minus plus 1 is equal to bi plus c. So what you have here would now be 6 plus 24, that's 30i, minus 8 plus 8 is minus 10 over 10 is equal to bi plus c. So this becomes 3i minus 1 is equal to bi plus c. Now if you compare, so that b is equal to 3 and c is equal to minus 1. So from what we have here, a, so this is b and this is c minus 1. So a is what? 2 over s plus 3 plus, what is b? 3 s. What is c? Minus 1 over s square plus 1. See s square plus 1 now, over s square plus 1. So this would be 2 over s plus 3 plus 3s over s square plus 1 minus 1 over s square plus 1. Okay.